Hello, everybody. My name is Simon, and today is May 18th, 2017. And here are Andrew Baffon, Jonathan Byrne, Philip Liddell, and myself, Simon Boka, like I said, member of the team Doomguy. And we're going to introduce our project for virtual hackathon. All right. To implement our Pi Vision plugin, we use the Google Tango AR, that's augmented reality, to create an Android app that sets waypoint as we walk around a facility. The purpose of that is to create a blueprint of the area, inserting data source that are supposed to be our waypoint as we walk, and treat the picture that we get as a blueprint that Tango will help us get for that facility. And using our Pi Vision plugin, we're going to export this map and collect, view, monitor all the data at those specific locations. This project is a demo, and I think with further development, the project can be very useful to anyone from a business professional or maybe an on-site technician, in the way that it has the ability to view the real-time data from a specific location without even being there. Okay, now talking about the libraries that we use. So for that project, we use all the provided libraries, and in addition to the provided libraries, we use the Tango SDK library and the Tango support library to implement the Android app and being able to export all the other features. And my team member John, we go over the JavaScript implementation. Andrew, we explain the mechanism behind getting the real-time blueprint, and Phil will explain the logic behind setting the waypoint and drawing the picture. All right, thank you.
My name is Andrew Bathon, and I'll be explaining the logic behind exporting the image of the floor plan to the JavaScript symbol. First, when we create the bitmap, we need to make sure that we double the width and the height of the image. This allows us to get a larger image of the floor plan in case we go beyond the size of the screen, and is also needed in order to properly scale the image and the JavaScript symbol. This will also serve as a temporary bitmap so we're able to instantiate the canvas properly. After this, we need to capture the image that is currently on the screen. This is done by passing the bitmap object into the canvas object. After that, we need to call the doDraw method so we draw to the canvas one final time. After we capture everything we need from the canvas, we then use a random number for the naming convention, so we have a distinct way of identifying the images in the gallery. When the image gets captured from the canvas, we need these necessary lines of code in order to make the images visible in the image gallery on the phone. This makes it easier when we export the image to the JavaScript symbol. Finally, we need to export and compress the image as a PNG image and clean up the bitmap/close the bitmap object. In order for us to access the gallery or the camera on the phone, we need to ask a user for permissions through the Android SDK, and these permissions are outlined here.
My name is Philip Little, and I'll be talking about the methods we use to actually make the waypoints in the Android application. So the first thing we had to do was create an on-touch event so that when you actually touched the phone's screen, it would have a waypoint where you placed it. So all that needed was it's a method that's overridden because it's already in Android. So all we did was we got the canvas where the map was being drawn. We got the X and Y coordinates of wherever you touched and placed those in a point. And then we added that point to a list of points that we would later use in another method to actually draw the waypoints onto the screen. So that brings me to the do-draw method. Now this method is the method that runs on a thread in the application that is constantly going unless you hit the pause and resume buttons. So this thread is just constantly drawing everything that the camera is picking up as a wall or a table or so on and so forth. So since this is constantly basically redrawing every time it erases the previous image, it gets your current position. So it starts drawing from the center, which is where your current position would be, and then it concats the canvas with the actual Tango camera, so that it will update the position based on the device's the camera's position and orientation. So then as this is going, it gets all the polygons from the camera and starts drawing them, and it uses the paint based on what the algorithm determines the polygon to be. So if it's furniture or a tabletop or empty space or a wall, it'll use different colors. And then after that, it creates a path between. So basically, it gets two vertices of the polygon, and it makes a path. So this is usually for walls. So it makes a path to just draw the wall. And then we get to the part where we actually draw the points. So we use the point list that we made in the on-touch events. And so basically every time the do draw thread runs, it'll draw a circle where the waypoint is, and then it'll put a point in the center of that circle so that when we move it over to the JavaScript, we can determine where the points are in the image. So I think it's a slightly different RGB value. And also we had to manually determine, because there was some offset, so we had to manually determine the offset for the X and Y points. So that's what you see the 703 and 1380 numbers are there.
Hello, my name is John Burns, and I will be taking a look at the JavaScript portion of this code used for the custom PyVision symbol for Team Doomguy. First of all, we have the initialization. Several functions are defined here, including the image loading function, the data update function, and the onDestroy function, which is for symbol deletion. First up, I want to talk about the data update function. So this function is called every time a point that is associated with a piece of data in the symbol updates. Whenever that updates, first the symbol goes through and sees if there are in fact hover items and data items already initialized. If there are, it'll grab that list from the global scope, and if not, it'll create a new list that contains all blank values. Then it will go through, and if the number of hover items is greater than the number of data points associated with the hover items, it will apply this text to the last hover item. It will tell the user to drag in a point to associate it with the waypoint. Otherwise, it will just increment that value, so next time it will check the next hover point. Then finally, for all the points that already do have points associated with them, it will go ahead and export those so that they are seen by the user and the data actually does in fact update. Next up, I'll take a look at the function loadImage. Starts off here, we have several variables just to get everything set up so we can start working with the canvas and whatnot. We have an offset, which just makes the hover image show up better. And first of all, we go through and parse the entire canvas pixel by pixel, trying to find a pixel with this specific value right here. This is a pixel with a value of 254 of red, 0 blue, 0 green. This means that this is a very red pixel, and when we're deploying the code, we have exactly one of those in the middle of each and every waypoint. So those are very easy to find. We add those to a list. Next, we go through, and there are several different colors here that correspond with the current location. That is exported with the image as well. That is not necessary information for the map itself, however, and we simply replace all those colors with the background colors that they would have been if the current location was not visible. Next up, we go through and set up a bunch of hover items at every pixel value that we located successfully. So what we do is we set up a hover item object with the actual X and Y values plus whatever offset we need. And then we give it an ID that is unique to every found value. Next, we make that list global. We make the number of hover items global as well. We draw the image and we hide the upload portion, which is how the image is actually imported into the symbol itself. I'll go over that in just a minute. Next, the destroy function just goes ahead and cleans up some of the stuff we made earlier. This right here is the definition. We need this to actually define several constants about the symbol, such as its name, its display name, the data source behavior, which allows us to add multiple points to this symbol. We load the icon, and we set up several more things, including the size of the window, and due to the scaling mode we use, this window is not allowed to be rescaled. And that allows us to easily associate the waypoints with the actual locations on the map and make sure that those don't get moved around when the image is resized. Finally, we have the load file function, and the entirety of this function serves the purpose of allowing the user to upload the actual map file itself. The video demonstrates this, and simply put, this allows the user to upload any image they want as a map.